screen?
Sorry?
Can all of you see my screen now?
Not yet.
Hey, just let me know once you are able to see my screen, okay?
Yeah.
Sure.
Hello?
Still not able to see.
Yeah, I think I've shared. 1 minute.
Yeah. Hello.
You're able to see my screen or still it is?
Yeah. Now, yeah, I can see.
Hey, Gopu, what about you? Are you able to see that?
No.
Abdullah, are you able to see my screen?
No, I can't see.
You can't see. You
No.
can see or you can't see.
I can't see your screen. There is
Hey,
nothing.
okay, Gopu, are you able to see my screen?
No, Gaja.
Hey, there would be somewhere you should click actually. You're using this first time?
Yes.
No, you should
I,
you click on my side actually. You should click on my side.
okay. Where to do that one?
I'm calling you. Can you take the your WhatsApp call? I'm just calling you.
Okay.
You have to click on my this thing. You have to click on my screen. Hello?
Mm, not there is just picture.
You're getting error. Okay, he's not able to see it.
I can see. No.
Huh? What?
Gajanan, I can see. Nilish. Nilo. Now,
Just 1 minute. Just 1 minute. Sure.
Yeah, right now it's working. Yeah, for me it's visible.
Gopu, you are still not able to see. Just can you show me the screen? Just your screen. Gopu, I think Gopu, can you check whether you have a latest version of Skype? Gopu, are you still facing issue? I think 1 minute. Hello? Hello?
Yeah, hello.
Yeah. Hey, Gopo, are you able to see?
No, it's again actually.
I think we lost connection.
Hey, hello? Hey, are you able to see now?
Yes, Benjamin, I can see.
Gopu,
I think Gopu lost the connection.
Gopu, call me again, call me again. Hey, wow. I think I lost 1 minute because he is not able to see. Hi, Gopu.
Yes, I can see now.
Okay, now you can see the screen, right? Yes.
Yes.
Okay, so let's start. Okay, I think we have spent a lot of time to make this arrange. Okay, so let me tell you, we are starting with the network fundamentals. So basically, we will look into like how the packet flows through TCP/IP model. Okay, and if you have any questions, uh, uh, if you have any doubt, you can ask me at the same time. Okay, then I will able to answer that. Okay, so as you said, because when we talk about networking, we usually talk about two models. Okay, so what are those models? Do
One is I and TCP/IP.
Yeah, so one is the OSI model and one more is the TCP/IP model, right? So if you look at my screen, I have these two models, right? So if you see this, right? So right hand side I have OSI model and left hand side I have a TCP/IP model, right? So you can see the screen, right? So basically, if I look at my TCP/IP model, I have four layers: application, transport, network, and network interface layer, right? And you can see, right, the corresponding layers of OSI model representing those layers as well. So if I say application, presentation, and session, that basically relate to my application layer. And when I talk about transport layer, that would be my transport layer at the other side. Okay. So if I talk about a network layer of OSI model, I'm talking about the network layer of TCP/IP layer. Okay. If I talk about if I talk about data link and physical layer, I'm talking about the network interface layer. Okay, so now the network fundamental starts. So do you guys know, let's say I have a computer over here, okay, right, and I have one more computer over here, okay, and for a basic functionality, let's say I don't have any kind of networking devices, okay, I can just connect them directly via cable, right.
Yeah.
Yeah. Hello. Hey,
Yeah, hello.
Gopo, Nilesh, are you able to understanding me, right?
Yes.
Yeah. Yeah. Nilesh, are you there? Hey, Nilesh. Okay. I don't know whether he's there or not. Let me just ping him. Okay. So, yeah. So, if I talk about, let's say this computer is name is A, okay, and if the other computer name is B, and now they are trying to send some kind of information, right? So where this cable goes, do you have any idea, Gopu? This cable?
What's your question?
You connected directly, correct?
Yeah, where I will connect this cable?
NIC, network
Yeah.
To
interface.
the port?
So yeah, that's correct. I'm gonna connect this cable to my NIC, right? Network interface card of this guy and network interface card of this guy, right?
Yeah.
Now once I connect them, what happens? So let's say this guy want to send some information. Let's say he want to send I can take an example of A, right? He want to send A to this guy. What happened behind the scene? I want to
Yeah,
send
okay.
this word A from computer A to B. So what will happen behind the scene? Any idea, Gobu? Or any idea, Abdullah? What happens?
Can I send the acknowledgement? Right?
No, no, no. How does the
And
A
then,
will be transmitted?
Signals kind of things they will transmit.
Okay, it will directly be a
Maybe some
yeah.
signals.
It will be the
yeah,
directly a signal or what it is.
It no, it will send in the
signals.
bits. It binary, yeah, zeros and one.
Yeah, yeah, yeah. It will. You are right. So it will take that A, right, and it will convert that into the bits, right. You can say A if you want to represent the A, you can use this 8 4, right, 2 1, right. So if I say A is if I do 1 here 0, right, and 1 0, right. So this is the data I'm gonna send. Because why I'm gonna send 1010, because the computer doesn't understand A, right. What computer understand is basically a digital, right, digital numbers. That would be my ones and zero, right. That's what the computer understand. Okay, right. So now if I want to send a 1010, right, how does my network interface card deal with it, right. How does my network interface, what kind of signal my network interface card sends? Any idea about it? Anyone can answer it.
Uh,
What was your question?
Yeah, so I have converted my number A into 1010, right? Because computer only understand bits, right? It can only
Yeah,
understand,
fine.
yeah, binary number, right?
Yeah,
Because what we are doing is here a digital communication, right? So I'm sending a 1010. How does my network
yes.
interface card deal with it? What it does?
save it as a packet, right?
No,
Like,
no, no. It will not send as a packet because already I've converted this packet into this ones and zero. What happened next?
yeah, take it back, like,
Yeah. So
convert it.
see, I told you, right? This is a cable, right? I need to send something. I cannot. That needs to be represented something as well. My computer will understand the binary, right? Ones and zero, and then my cable should understand something, right? If I'm talking about the copper cable, I need to convert this 1 and 0 into electrical signals. Okay, I will convert them. Okay, I just write it down here. I will convert these into electrical signal, right? So what if it is a fiber cable?
Voltage, right?
Yes.
Let's say this is not a cable,
That
copper cable, and let's say it is a fiber. What will happen in this case?
Light speed or something like that.
What?
will send optical signals.
Yeah, what we call them? What we call the optical
Speed,
signals?
speed of light or something.
Those are called the
Light.
lights, right?
Light,
Lights, right?
Yeah,
Yeah,
lights.
yeah. So basically, if it is a copper, it will be electrical signal being sent. Okay, and if it is the fiber, it will be my light. Okay,
Rebel.
yeah. So understood?
okay. Yeah,
Yeah. So basically, how does it does? They've uses a different kind of encoding mechanism. Okay, I could take. You
yeah.
don't need to
Or
worry about
wireless.
it. Hello. Yeah, you don't need to worry about these all the schemes. Okay, I'm just giving you the just an overview what happened behind the scene. Okay, encoding scheme,
Okay.
what it does is, let's say I'm sending a 1010, right. What it does basically, it takes a 1 and it convert them into some kind of voltage. Let's say if I want to represent a 1, I'm gonna send a 5 volt signal over this wire. Okay,
Mm.
I will convert.
Also,
Yeah, you are right. I will convert that into the 5 volt. Okay, and now if I am sending 0, I'm gonna send a different volt. Let's say I'm sending a volt of 10, right. 10 volt. This is just an example. Okay, so basically to represent a 1, I'm gonna send a 5 volt. and to represent a 0, I'm gonna send a 10 volt, because if I'm sending these volt, 5 volt, 10 volt, again 5 volt, 10 volt, then this guy will intercept this guy will come to know that, yeah, I am getting a 1010. That's how it basically able to represent that current into again 1 and 0 and 1 and 0. Okay, you got it what I'm saying?
Yeah.
So yeah, so first thing you need to remember, whenever the data comes, that will be converted into the 1 and zeros. Okay, 1 and zeros. And then depending upon my encoding scheme, I can give an example. One of encoding scheme would be Manchester. You can write it down if you want to. This is the encoding scheme. Okay, so let's say this is where you can do your first level of troubleshooting. Let's say this guy is using a different encoding scheme. Okay, and this guy is using a different encoding scheme. Will they able to communicate in this case? No,
No.
right? Because
Yeah.
one guy will say 1 volt. If let's say the one guy is saying that the 7 volt represent my number 1,
That
right?
will be correct.
Yeah, the encoding schemes needs to be corrected, right? It should be corrected so that they able to communicate, right? You got it?
Yeah.
This is just like a brief description what happened behind the scene. Whatever the signals I'm sending, that all the signals will be converted into the electrical signals. If it is a fiber, that will be converted into my uh, uh, light signal. Okay. Are you able? Do you have any questions regarding this, Gopu?
No,
Hello.
Gajan.
Any
No.
question, Nilesh? Fine, right?
Just want to know, Gajanan, so how fast it does? Like, is it like frequency? The frequency is measurement. One frequency measurement is there, right? So that switching is done on the frequency, like how fast it is doing, or some kind of thing.
That depend upon what is the what do you say? What is the
Connection.
speed of your network interface? Okay, how fast it can transmit the data, right?
Okay, so
So
when we talk about like 10 MB, so 10 MB data per second it will send, right?
yeah, you are right, correct. 10 MB data per second it can send.
Okay, Gajanan,
Yeah. So
thanks.
don't worry about much on this. Okay, just understand my binary will be converted into the electrical signals, and those 1 and 0 again will be represented into some kind of voltages, so that other guy will be able to understand it. Okay, got it?
Yeah, Gajanan, thank you.
So now let's say what happens now. Let's say we have a two computer here. Okay, let's say we have a two computer. Okay, let's say we have a computer A here,
Mhm.
and now this guy is trying to communicate somewhere. Let's say this is a cloud. Okay, internet. So this is where we will talk now. Okay, basics communications, how this works behind the scene, right? This is my internet, right? Okay, and I have a google.com. It could be anything. Okay, it could be the same for everything. The communications remain same. Okay, so I have a computer which is trying to communicate with google.com. Okay, very simple. It could be your own server. It could be anything. Okay, anything will go through these processes. So we actually what we'll do is we will take that everything. Okay, we will compare them. Okay, let's talk about it could be any file. It could be ftp file, it could be dns, it could be any kind of applications. They all go through these process. Okay, so let's talk about it.
Okay.
Okay, so let me type first thing. Any idea what happened first, Nilesh, or if I type google.com, what happened first, do you know?
It will result
you
the to
yeah,
DNS.
you open the browser. Okay, why do you use the browser? Any idea?
To access the
Yeah, so
URLs,
yeah,
like
yeah,
First,
applications.
it's from.
yeah, to access the url and other things, right? We use a browser, right, for that, right?
Mm-hmm.
Yeah. So now browser comes under where? Browser comes under which layer of the OSI model?
Application.
Yeah, you're right. Applications, right? So now, that's what. When we open the browser, we are actually using these things. We are going. If I talk about TCP/IP layer, OSI model, I'm going to application layer, and when I type this also, this is where it comes under application. If I compare a TCP/IP model, this is where I'm touching now. Here also, this is where I'm touching now. Okay, what happened now? When I type google.com, first thing what will happen? If I type www.google.com on my browser,
It has to
which
figure out the part.
you are right. So do you know, Nilesh, what happened when you type www.google.com? First thing.
It will result to the no, first, like it will send request to that particular server.
Okay,
When
what
we
which
type to
server?
Google, where this application or URL is
Yeah,
hosted on
yeah,
that.
yeah, yeah. Before that, something different happened always. Okay, it's not directly in the one. What is the current phone
Send.
location?
Okay.
Okay, so basically, what happens behind the scene is something known as the port resolution. Okay, that's the first thing will happen, not DNS resolution. Okay, this is, I think everyone knows only about like a DNS resolutions. That doesn't happen first. Okay, something happened known as a port resolution, right?
The part resolution depends with the HTTP, FTTP, right?
You are right. You are right. Yeah, I'm just talking about it. Okay. So this is the port resolutions. Nilesh and Gopu, what happened first is the port resolution. Because see, when you
So,
type www, right? Do your computer know what exactly www? No, it doesn't know.
no.
It doesn't know the name, right? That's why that this needs to be converted back, right? This needs to be converted into any number, right? That's the first thing will happen. What happens? It convert the www dot into in some name, okay, some number. Okay, let's say if I'm using a FTP, what would be it is? It convert FTP into port number, right? Or you can say any application, let's say SMTP, SNMP, whatever it is. Okay, you type those things, that will be converted into the number first, because my computer only understand the number. It doesn't understand any name, right? So first thing will always happen is the port resolution. Okay, and you might ask where these files, how they come to know the port resolutions. They come to know the port resolution by a file called as the etc directory. Okay, that etc directory will be there in all the operating system. Okay, etc directory will have a service file. In that service file, I will have all the port number. Okay, all the port numbers are predefined in that etc file. Okay, so basically when you type www.
It's defined. It's defined for HTTP,
Yeah, you are right.
FTTP,
You are
all of
right.
these.
You are right.
Okay.
It defined for
And each one
everything.
is different, right?
What?
And each one is different, like
Each one is
HTTP,
different. Yeah,
AT, FTTP.
yeah. Each one is different. If I say HTTP, it will be port 80. If I say HTTPS, it will be 443. Okay. So you have to
Okay.
go to the.
What about HTTPS? Is it different from HTTP?
Yes, yes, yes. Obviously, because HTTP is unencrypted, right? You are
Yeah.
sending by when you use HTTP, you are sending a data without encrypting it, right? So when you do
Okay.
HTTPS, that will be encrypted, right? So they need to use
Okay.
a different port number. You can see, right?
Okay.
You can write it down. This is the file where you will see your all the ports number, etc file.
Okay.
So
And this, like the port resolution, it's considered on the application layer, right?
yeah, this is
That's it.
you are right. This is all the application layer. What I'm doing is everything is application layer here. Okay.
Okay.
So, Gajan, this ETC file is inbuilt in all computers.
Yeah, Nilesh. It is inbuilt in all computer. You can just Google it and you'll be able to see where you can find it out. Okay.
Okay,
Yeah.
thanks.
So that's what happened. So now how you will do troubleshooting here? So let's say some users say, right, I'm not able to access some file, and
Mm-hmm.
that's your first level of troubleshooting. You go and check the etc file. If someone is doing something with the etc file, let's say someone went there and he typed www is equal to port 70, then you are, yeah, that will not happen, but I'm just saying, okay, this is where you need to look into. If your port resolution will fail, then you'll not able to communicate, right? Because port 80, port 70, nobody knows, right? So if there is someone is played with your etc file, that's where you look into first, right? Means your port resolution is failing, right? That's the first thing you need to look into. First, what happens? My www.google.com will be converted into the port number. Okay, you got the port number, right? Your browser got the port number. What happened next? So any question here
DNS.
about the port resolution, Gopu? Is it clear?
Yes.
Yes.
Okay.
If I have viewers again this question.
Hello?
No. Right now there is no any question. But if I get any
Okay.
question on this, I will let you know.
Yeah, fine. So now next what happens, Gopu? You got the port number, right? You have a port number. Your computer have a port number. What it does next?
Now the DNS resolution, right?
Yeah, now it's check the DNS resolutions. Will it send a DNS packet to directly a DNS server? Is it does something else?
No.
Yeah. So what it does first? Abdullah, I think you know, right? This answer?
Yeah.
Yeah, what it does?
Check the local cache.
Okay.
If it has the data, it's just gonna bring it directly from the cache.
Okay.
And if it's not, it's gonna check a text file that matches names of the website with the IDs.
Okay.
So if it's not there, then it's gonna go to the DNS
Okay.
server, and
Okay.
it has its own part. I
Okay.
think it's
So
linked with the TCP.
now you are saying how many things it checks? What are the things it checks? So you said one is a cache, right? After that, what happens?
If it's not in the cache, it's gonna check a host file.
You are right.
File.
Yeah.
It
Correct.
has all the website and their ID.
Yes, you are right. So
So if it's not in the text file, then it's gonna go to the DNS server.
okay. So that's the thing. What happened? So just hey Nilesh and Gopu, you need to look into here, right? When you type next thing, what happened is known as the DNS resolution. Okay. So DNS resolution is why do we use the DNS resolution? Because my computer doesn't know, right, what is google.com. He doesn't know google.com. He doesn't understand the name, right? That needs to be converted back to the IP address, right? And then that IP address will be converted back into the zeros and one, right? So now for DNS resolutions, it looks into three main parameter, okay, three ways, okay. As Abdullah said, the first way is look into look into my cache file. What is cache file? Uh, what is cache file, Gopu? Do you know what is cache file?
I think Goku lost the connection.
Oh, he lost the connection. Okay.
Cache is locally stored somewhere.
Yeah, if you have opened it before, you can store it.
Yeah. Let me add him. Hey, Gopu. I think he's. I'm not able to reach him on my. Yep. So you are right. So basically, cache is where it is locally stored, right? So what about host file? Uh,
Host means
yeah. So there is one more thing. Okay. first it goes to the cache file, okay, and cache means it
Yes.
basically check is that is that host name is there in that cache file or not, is there any IP address is not there or not,
Uh,
okay.
is the cache file on the computer or on the
Yeah,
router?
it is on your computer, Abdullah. Okay, it is on your
Okay.
computer file. Okay, then you have a host file. Do you know host file? What exactly a host file, Nilesh?
No, Gajanan.
Okay, so host file, let's say earlier days we used to not use the DNS name. Okay, we used to not use the DNS name. There was no DNS. Okay, earlier what they used to do is they used to have all the DNS entry. Okay, host file is only a text file. Okay, it's basically a text file, okay, which actually have a manual mapping, means it used to have like this: www is google.com and its IP address is 172.1.1.1, something like this, okay. www www.cisco.com, okay, it has the file it has the name of 142.1.1.1, okay, like this. So it is a text file which have all these entry, okay. So it basically go
Okay.
and check in the host file as well.
Okay. The second step is that host file. It will check in host file.
Yes, correct. Second step is it look into the
And the
host
host
file.
file is in the computer or
Yeah, that host file will be in the computer, okay. See,
but doesn't the ID changes?
what?
Does the ID changes, like for
No,
example
no,
if
no,
it's
no, no.
all
The IP address will not change automatically. IP address are statically mapped. I said it is a manually mapped. Okay, it is manual. What do you
so
say?
is this in the operating or how does it create this file?
This is an operating system, Abdullah. You can check this host file in your computer as well. Okay.
Okay.
Yeah, just note down of these points, okay. Might be these things are new for you guys, so just note down of these guys: what is a host file, what is the etc service file. So these might be a new thing for you guys, right? Just note it down, just do some
Yeah.
Google, you will be able to find it out where it is, okay.
Okay. And DNS resolution, which layer does it happen?
Yeah,
Still in the
this is
application?
where it happens, the third line, okay. This is where the packet is sent over the wire, okay. If I don't find my IP address on the cache file, if I don't find the IP address in the host file, I'm gonna go and send a DNS query, okay. I'm gonna go and send a DNS query to whatever the DNS server is configured, okay. That
Okay.
DNS
So
server, okay.
number one and two is still in the application.
Yeah, these all would be the part of applications, okay.
Okay.
Yeah, so
Number
basically,
three is different.
what?
So one, two, and three, it's all in the application.
You
So
are right.
just one and two.
All in the applications.
Okay.
These things will happen in application, but when the DNS query is sent, it needs to go through all of this process. It needs to go through the network layer, uh, transport layer, network layer, and network interface layer. Okay,
Mm,
right? So in
okay.
our cases, we are not going to send a DNS query. Let's say we got the file from the cache. Okay, I'm just assuming that I got the file of DNS from the cache because my computer did it for me earlier. Okay,
Okay.
got it?
Yeah.
Yeah, so now that's the DNS resolution. I got the what do you say, I got my IP address as well from any one of these process. Okay, I think he's trying to join 1 minute. Just 1 minute. Hey, Gopu, can you hear me? I think he's having some issue. Okay, so got this. Hey, Nilesh, you got this right?
Yes,
Yeah,
Gajan.
these are the steps. Okay, nothing will happen fancy. So you need to see. I'm just telling you where the packet being sent. So you might see in your cases when you do a packet capture, you might see that DNS packet has not been sent, right? When you do a packet capture, that
Yeah.
means the DNS resolution is done by using these two methods. The third method only it send a DNS packet. Okay, always. It
Yes.
doesn't use
So I
any question.
just want to know if you have any error snaps of that packet capture, so it will be if not not now, just in next class. If you have some error
No, no, no.
snaps.
I'm actually in this class only. I'm actually I will show you how this all things happen. Okay. So
Okay,
yeah,
okay, okay.
yeah.
Thanks.
Everything will. This is important class. I will just complete everything now today only. I will give you the. I will set up the lab for you guys, and then we'll have a look into the how the packet flows. Okay.
Okay.
Yeah.
Hey, Gopu, are you there?
Yes, yes, Gajan.
Yeah. So what happened now? So did you hear this? First thing, what happened?
First, it will check the etc file, the code numbers.
Yeah.
Then it will check the cache.
Yeah. No, no, no. This is for port resolution. Okay. This is for first step. That's done, right? You forget about it now.
Okay.
You check the etc file. Done. You are fine. Now, next thing what happened was the DNS resolution. Okay. Okay.
Okay.
So DNS resolutions means right? Domain name into the IP address, right?
Yes.
Yeah. For that, it needs to know the IP address of the google.com, right? This is where it look in.
Okay.
This is where it first check the cache file. Cache file mean it will check its own memory first. Okay, cache means it's a local memory where it might have the entry for the DNS. Okay.
Okay. In that entry, it will be their IP address and that regarding that URL.
You are right, correct.
Cache file.
That's correct. That file will be there. Okay. And now the third, if there is no file, let's say there is no file.
Okay.
Okay, there is no entry in the cache file. Okay. The second thing it does look into the host file. Okay. There in each and every computer we have a host file. Basically, host file is just a manual mapping.
Man,
Okay. It's a manual mapping of the domain name to the IP address.
manhole.
Okay.
Okay.
So that
Just a second, please.
Okay, so basically the google.com will be typed, okay, will be typed 170.1.1.1 manually. The cisco.com 142.1.1.1. It would be typed manually by the system administrator or through the computer, okay. We can modify that file, okay. That is the
Okay.
txt file, just a txt file on your computer. First, if I don't find any entry on my cache file, I'm gonna look into my host file. Okay. If there is nothing in the host file, then I'm gonna send a DNS query. Got it?
Okay.
This is where when you do a packet capture, you will see a DNS query here. If there is if it is not able to find, if it is failed to find the IP address from cache file, and if it is failed to find the IP address from the host file, then the DNS query will be sent to the DNS server, right?
Okay.
You know where is the where do you find a DNS server?
Local DNS server,
You are
right?
right, correct. That's called the local DNS server, right? Local DNS server setting will
Yes.
be used, IP address will be used to send that packet. Got it?
Okay.
And sometime
Yes.
if you're not able to see the DNS query, that means it got that information from the cache file. If not from the cache file, it got that information from the host file. Got it?
Okay.
Right? Any question here?
Yes. Yes. In that host file, everything will not be there, right?
No, no, no,
Only
no, no,
packet
no.
will be.
Everything will not be there. Nowadays we are not using that host file much. Okay, it's
Okay.
see earlier days, earlier time, right? There was no DNS server. Okay, there was no
Yeah.
means when right, the network growth was very slow. No, not very slow. They have done everything was not built at the same time, right? So that's why the switch was not built before bridge. First they have built hub, then they have built bridge, then they have built switch, like that. The same thing here. They didn't build a DNS server directly. They didn't had the didn't know what to do, how to do. Then they have created the host file by computer in the computer itself. Then they have built the DNS server. Got it? So
Okay.
earlier we didn't have a DNS server. That's why they used to use something known as a host file. Okay?
Okay.
The host file depends on the operating system, right?
You are right, correct, Abdullah. It is in operating system instead. Got it? So now I got my IP address. I'm happy. My computer is very happy now. He got the IP address, right? What happened next? What happened next? Any question? Any idea?
With the DNS query.
Yeah, I got the IP address. My computer is happy now. He got the IP address, right? So now what happened next?
Just can open the website.
Yeah,
browser or-
it opens the website, but what it does, what protocol it use?
It depends. If it's HTTP, it's going to be TCP.
Yeah, so for HTTP, it uses a application protocol. We are still in the application where this guy uses a HTTP. Okay, HTTP it needs to get what do you say? It needs to get a web page, right? It asks the web page from the what do you say? From the google.com. It needs to ask. So in the HTTP, I'm gonna send a request. Okay, you don't need to worry much about HTTP. I'm just telling you what request it is. Okay, HTTP get request.
Yeah.
Okay.
This is when it finds the ID.
Yeah, it finds the IP and it is now building the data, building the packet. Okay, it's trying to build the packet now. Okay, it finds the IP now. It know everything. Okay, now it's trying to build the packet. Okay, HTTP get request. That's the get request here. Okay.
Okay.
Yeah, this is the at applications, right? We are still at the application now because I'm just telling I've not used I've not sent any kind of DNS query. I'm just telling that I got my IP address from my cache file. Okay, so I'm not gonna send any kind of DNS query to my DNS server. Okay, that's why I'm go and send create a HTTP request. Okay, I will just type here like HTTP request, HTTP get request. Right, means I need the web page. It basically asks give me the web page. Okay, so this is the request I'm gonna send through my all the application layer. So now what comes, see, you need to see the diagram very well. Okay, I'm talking about now from the application layer. I've typed www. That means I'm gonna use the HTTP by default. Okay, it is port 80. Now it needs to go down, right? Before that, if see in any time when I'm talking about the packet flow in the network, I'm not using, we don't use the OSI model. Okay, we don't use the OSI model. We actually uses what do you say, we actually uses the TCP IP model. Okay, nobody uses a OSI model. OSI model is required at the first time if someone is very new to networking and he need to understand what happened behind the scene, what happened in the computer itself. Okay, do you guys know one question is, do you guys know what do you mean by presentation layer?
Presentation.
Yeah, presentation layer in the OSI model. Gopu, you know?
It will keep.
It will use to display the data, right?
Yeah, you are right. It is used to represent the data, right?
Yes.
Yeah. So now, what is the data that could be? It basically takes the data from the application layer. Let's say we have a two computer. One computer is a Unix computer, and one more is a Windows computer, right? Unix computer and Windows computer have a different format, right? They don't have a same format. So what my presentation layer does, it takes the, let's say his Unix computer is sending something to my Windows computer, right? So what it does, it takes the data from the Unix computer and it converts that into the standard format. Okay. Now when this data being sent, the other way around, other presentation layer convert that standard format into the readable format of as per the Windows computer. That's what my presentation layer does. It presents the data to the application layer. Okay, and the other thing it does is basically it can do compression, decompression, encryption, and decryption. Okay, so let's understand that it presents the data in some other order. Okay, got it?
Okay. And TCP IP, it works for everything. That's why they converted to it, or what?
Yeah. Yeah, you can say like it comes on these things are right. These things are is part of my operating system basically. Okay, it's part of the application layer basically. Okay, that's why in TCP IP layer we are representing this as a one layer. Okay, so whatever I'm sending is here is my data itself. Still it is a data for me. It is it when it comes to the transport layer it will change. Okay, but still here it is the data for me. Got it? Any question? Hello, any question here?
No, Gajan.
Abdullah, do you have any question here?
No.
Yeah. There is one more thing. I'm just completing these three things. What it is, you might because we directly will go to the transport layer then. Okay. I'm just talking about the session layer. Do you know what do you mean by session layer?
Yeah, it will keep session open.
Yeah.
Like,
So yeah, the best example would be for that. Let's say I'm creating a google.com, right? I've typed google.com on my browser, okay, but I got some information on the browser, okay, and I went one more session. I've created one more session on other side. I've just typed the www.google.com. That means I have a two session now, right? My computer needs to identify where the data goes from which browsers to which browser, right? So it needs to know, right? That's what the session layer is does. It keeps the session. It keeps the data separate. Okay, got it? Got it, Abdullah?
Yeah. Yeah.
Yeah, I'm just
yes.
telling. I'm just taking the example of this. Okay, nothing. I just type here like google.com on one side. I've typed something google.com on other side. It's same like this. So if I go here, right? I just went here. I just typed something here google.com on this side. Okay. I went type here something here as well on this side as well. These are my two separate session, right? Right, so these are my two separate session, right? google.com is here. I have google.com over here, right? So when I type something here, if I type anything like cisco.com, here is the separate data, right? These two data are separate. So that's what my session layer makes sure that these data are separate. If I type here cisco ccie, that is something different over here, and that will not come here, right? So these are the two separate sessions. That's what my session layer does. It keeps the application data separate. Got it? Any question over here? Hello?
No, Gajan.
Hey Abdullah, you got it right? I think we lost him.
I think he is there. No, we lost. We lost.
Okay, till what time you will be there, Nilesh office? I think it would take I think 30 to 40 minutes. You are there, right?
Yeah.
Okay, after this, okay, I think he is.
It looks nice. Huh?
Hey, Abdullah, are you have joined? Yep. I think we're not able to reach him. Hello? Hey, Gopu, are you there?
Yes, I'm here.
I think I lost him actually.
I'm also.
This one.
Goku, are you in office?
51. Hello?
Hey, you have joined, right?
Yes.
Yep. You got it right? What I was saying? You know,
Yeah.
yeah, that's fine, right? You application, presentation, session layer is fine, right?
Yeah.
Yeah. Okay. So now what happened next? I said HTTP, and I said what happened. What exactly HTTP request is will be encapsulated? What happened next, Gopu? Or anyone can answer that, Moshes. So what happened next?
The light data means
Can I
CV, right?
transport?
What?
Can I ask TCP for permission for the port number?
You are right. So
Yeah.
basically, it's gonna use a TCP, right? Right.
Yes.
So why does the HTTP uses TCP, and which protocol uses a UDP? Why it uses a TCP, or why it not uses a UDP? Uh, uh,
TCP. Yeah, TCP is a reliable protocol, so
yeah.
it will not lost any packet. If it lost, then again it will send request.
Yeah, that's correct. So it depends upon what kind of application I'm using, right? I said I talked about it that if it is SNMP applications, I'm gonna use if it is SNMP, I'm gonna use a UDP, right? And because I don't want reliability in that, right? So it depends upon what application uses, right? What actually how they are built. Okay, it depends upon our programmer who built that applications. They can either use a TCP, they can either use a UDP, depending upon their requirement, right? So why UDP? Why SNMP doesn't use a TCP? Nilesh.
Why what?
Why SNMP, right? There is a protocol for SNMP. We use SNMP for a monitoring. I think in last class I talked about it,
Yeah.
Abdullah, right?
Yeah.
We use
For
a
monitoring?
we use SNMP for monitoring, right? We actually the company uses you have their server. By using the server, they monitor all the devices, right?
Yes.
Yes.
So I'm asking why SNMP doesn't use TCP? Why it uses a UDP?
Because maybe it's gonna be faster to get connected to monitor all the devices.
Yeah, if you look at the
And
SNMP application, yeah, if you look at the SNMP applications, right, we are doing a query here, right? We are doing a query. Just one minute. We are doing a query for lot of what do you say? Lot of clients, lot of servers, or lot of this thing. And if I use a TCP,
a lot of overhead,
yeah,
right?
yeah, you are right. If I use a TCP, I will be having a lot of overhead, right? I will be sending a lot of packet. I will be having a lot of TCP sessions, right? So that's why we use the UDP. Because if you look at the SNMP, I'm going to ask the server. I'm gonna doing a polling, right? If I want to get some kind of information from the devices, I'm gonna use SNMP polling, right? So that polling I can do for every 5 minutes or every 10 minutes. So if I'm using a TCP, it will be a lot of traffic. Okay, that's why we don't use a UDP. That's why we don't use a TCP in the case of SNMP. You got it, Nilesh?
Okay.
Hello. Hey Nilesh.
Sorry, I was on. Yeah, I was on mute. Just one question here.
Okay.
So that for SNMP, it is not required TCP because TCP is reliable. So if we lost any packet, so that alarm system can create any alarm if they didn't get any packet.
Yeah.
So, so see, my question is that TCP is for reliable and UDP is not reliable. Only like streaming or
Yeah.
this kind of SNMP they uses, right? So in TCP we get authenticate information or like the data is rich or not. That is
Yeah,
we
that's
check
correct.
in
That's
TCP.
correct. But yeah, the question was actually why SNMP doesn't use a, TCP. That was the question.
Yeah, I understood, but just my question is that why SNMP is not using TCP, because SNMP should require this TCP protocol to get the actual information what
Just
is
one minute.
going on in
Hello?
the system.
You will get a lot of overhead. You will corrupt many data if you.
Okay. So to make the communication faster, they are using UDP.
You are right. See,
And
Nilesh, if you look at right, how does your SNMP work? SNMP do a polling for every 5 minutes, right? If you
yeah,
take any
yes, yes.
infrastructure company infrastructure SNMP gonna do a 5 minute. Every 5 minute you see, if you use a TCP, you are gonna create a TCP session for every 5 minutes, right? So that's why the SNMP doesn't use, because if I'm using a TCP, that will be a lot of traffic being sent, lot of connection being sent, right? A lot of overhead will be there. There will be a lot of traffic being flooded everywhere, right? That's why we are using a UDP there, because UDP is a connectionless. I just need a I just need to transmit the data at very high rate, very fast, right?
Okay.
And again, I don't need any kind of reliability there. I don't require any kind of reliability in the case of monitoring. I don't require that. And the second thing is, if it is SNMP is used in the very large deployments, basically, right? So that's the cases. I don't want to send a lot of traffic, lot of TCP traffic over there. That's why we use SNMP is hard coded to use the UDP. Okay. So that basically, if I answer that, if you answer that, that basically comes right. How the programmer, what programmer want? If I build some applications, it they need to figure it out. It's not our job. It's their job. What they want to use, right? They might use the TCP, they might use the UDP. That depending upon their requirement. Okay, got it?
Yeah.
Is it fine, Nilesh? Is that answer your question?
Yeah, Gajan.
Yeah. So now, if I look at my, I said like HTTP, right? I talked about it uses a TCP, right? So, and I think everyone know about the TCP, right? Uh, Gopu, do you know what how does TCP works?
Yes, Gaja, it will send first SIM packet,
Mm-hmm.
then it will send ACK, it will send, then it will wait till the reply from the other side.
Yeah. What is the connection we call them? We call that's called the TCP three hand way shake, right?
Yes, yes.
Yes.
Yeah,
Yep. So yes, let's say
that's the problem, right?
yeah, I've sent the data now, okay, and now I have to close my connections. What will happen in this case? What packet being sent from the TCP?
FIN.
Let's say I've created, as you said, let's say if I take a paint here, one more paint,
You're
right?
gonna send the final connection, then it's gonna reply the acknowledgement.
Yeah, you said I have sent a SYN packet, right? SYN, you send SYNAC, right? Right, and then you again send a ACK, right?
Yeah.
Now you both guys exchange the data, whatever the data is, right?
Okay.
Now I'm asking what happened next. Next, let's say you are a client and you have this browser, okay? And you are done with your search. You have searched some sites. You have went to the Google and you have done some search. You find. Now you are closing the data. What happened next, Gopu? I think Abdullah knows about it. Gopu, you know what happened next?
It will close the session, right?
Yeah, what packet is sent? Do you know that?
No.
Yeah. So Nilesh, you know that what packet being sent?
No, Gajan.
Yeah. When you close, right, it send a packet called the fin packet. Okay.
Which packet, Gajan?
Fin packet, fin packet. Final packet, final packet. It basically say, yeah, I'm done with the connections and I'm gonna close it.
Oh,
Okay. Then this guy acknowledge it. He say acknowledge, yeah, I'm fine with that. You are closing the connection, you are closing the browser, I can't do anything, I'm fine with that, I'm acknowledging it. Then after that this guy again say, yeah, let's close the full connections. And he also send my server also will send after some time he also send the fine fin, and this guy acknowledges back. Can you see this and how many packets I sent?
1, 2, 3, 4.
4 packets. So always my closing, right, it will be always a four-way handshake. Okay, you need to remember this, it is always four-way handshake. And my my connection, my starting, it could be a three-way shake. Okay, it could be a four-way handshake as well. But don't worry about the other four-way handshake. That is like this. There's some means if let's say I have some applications and they are starting the communication at the same time. So this guy is saying sin, as for sin here. This guy also saying sin, right? Both they are starting at the same time. This guy is saying act for that whatever guy, and he's saying act. So I might have a during the starting connections I might have a four-way handshake as well. But now right, but now you understand this. It would be a four-way.
Why?
What?
Why it has sometimes four?
Why it have four?
Yeah, why sometimes it has three,
Yeah, let's
sometimes
say this happens in the peer-to-peer applications. Okay, in the peer-to-peer application, the two computers start the communication at the same time. Okay, so let's
okay.
say a computer say I want to start, he send us in, this also guy send us in at the same time. This is comes in the peer-to-peer applications where they are hard coded to do that. Okay, and they send a
Okay.
syn packet at the same time. Don't worry much about it, but remember that there would be a four-way handshake in the peer-to-peer communications. Okay, in the peer-to-peer applications where both guy will start the communication at the same time. Got it?
If both computers want to communicate at the time, how the data are gonna be transmitted after the established connection?
Yeah, first they will establish the connection like this. He send a sin, he send a sin, he send a act for whatever the sin packet he sent, and it's the same thing. Okay, it's a three, it's a like a handshake only, but by using a four
Okay.
packets instead of three packets. Got it?
Why did they close the connection at the same time?
Yeah, they might they might close it. I don't think so they will close at the same time here, but they might it depend upon the applications. But I've never seen closing connections by using you can't by using a two packets. It would be always four packets. Okay.
Okay, so after establishing the connection, it's gonna be one packet for transmission.
Yeah. It would be yeah, that would be how much data they want to send. That would be your data, and then again the again my fin packet like fin and act for it like this. The same thing what I draw here. Fin packet send, act packet send, fin packet send, act packet send like this. Okay,
Okay.
got it? You got it, Gopu?
Yes, Gaja, for each and every session it will follow this step
Yes,
process, right?
always. When you type this thing, it will create this first, three-hand shake. Then after data,
Okay.
whenever you type anything, whenever you open the youtube.com, whatever you do, so this is what happens because this is a TCP, right? It is reliable, right? Why it does this? Because it needs to make sure that other guys, before sending something, he needs to understand whether that guy is alive or not, or he is listening to that port or not, right? That's
Okay.
why the TCP hands.
So,
Okay.
so Gajan, I just want to know, this will happen only once when we open the session, or in between also it will happen.
No. Once you open the session, it will happen. Three and Vishik. It will not happen other time. Until and unless
So once,
you close the connections, you do something.
okay.
Got it?
Understood. Yes.
This will happen always when you type google.com. I typed here google.com. I have a session here. I can see the session here. Basically, you have a command there for that. net stats. I think you guys know about this command, right? So can you see this? So this is how it would be like this, right? Uh, it would create a connection like this, established. I think you might know this established state. And you can see this protocol, right? HTTPS, right? And this is the TCP. So you can check your connection as well here. I think my PC is very slow here. So you will be able to see this. Okay? Got it? Any question here on this slide?
I think so.
Got it? Fine, right?
So one question is yeah.
Yeah.
One question is
Yeah.
so Gajanan, if when we do any packet tracer and if we see this like for a single session, if we see multiple times handshaking is happening, so is there any problem for that's why it is happening or it is like normal only?
Multiple connection means what connections? Multiple type connections.
Only one for only like I open YouTube only.
Okay, okay.
So at the start of session, it will happen and then session will be established, right? But when we do packet capture, in the packet capture for this particular only one session, but we see in like multiple times handshaking is happening. So
Okay, okay. Might be, see, when you open the youtube.com, right, or any other site, right, you need to look into the what IP address is trying to get into, okay? Because when you type something, when you type, there might be a link for other address as well, right? So there might be, it might be redirected to some other sites as well. So, but when you type youtube.com at the first time, it will create a one session itself. But when you click on the other URL, other something, it might go and use some other sites as well. That you need to just look into the packets. But as you said, if I'm just specifically talking with the google.com, I have to have only one session. I will not have a two session unless and until you might see some different packet. Okay, there might be a packet called as a TCP keep alive, that basically say, let's say I am not able to TCP keep alive being used to make sure the other side is fine or not. So these kind of packet you will see. Okay, apart from this, you will not see a different session for the same connections. Okay, but if you have some on the browser itself, on the site itself, you have some different thing, it might uses different connections for them. Got it?
okay, yeah. Got it.
Yeah. So now I've sent a HTTP GET request, right? Now my HTTP GET request use the TCP, right? Right?
Yeah.
Yeah. You understood? You are understanding, right? What I'm saying? I'm just going through because I want to make sure you guys understand that, right?
Okay, but before establishing the condition, it has to get out the port, right?
You are right. Correct. That's correct.
Okay, TCP.
That's correct.
Okay.
So basically, what happened? The data. What will happen now? So data will be divided. What exactly the second job of TCP? Gopu, what is the job of TCP? Second job.
It will make sure that the sender and receiving the data
Do you
with
know?
equal rate, right?
Okay. It basically adds the port number. Again, it does something known as the segmentation. Do you know about that segmentation?
To divide the packets, right?
You are right. It basically takes the data. This is my data here, right? It needs to. Will not go too much in the TCP. Okay. TCP. If you talk about TCP, it is. It would be like. It will be like a 8-hour session. Okay. Where I'm just giving you the what is the packet flow here. The data will be converted back to the segments. Okay. Like it needs to make sure the because I cannot send 1,000 bytes of data at the same time, right? I cannot send that because my MTU will not allow me, right? That's why I'm gonna divide the data into segment. Got it? This is also a job of a TCP to divide it into the segment.
Okay.
Got it, Nilesh?
Sorry?
You got it. You got this right. You got the concept right.
Yes, yes. I got this.
It again add the port number, like what is the TCP port number, destination port number, everything it add. Okay, it basically add the source port number, it basically add the destination port number. Got it? So what will be the destination port number here? Anyone can answer that? What would be the destination port number here?
80, right?
Yeah, you are right. What would be the source port number?
That varies from the 1023. That depends on the session.
Yeah, you are right.
It varies.
You are right. It would be from 1024 to 65,535. Any number, right?
Mm.
Got it?
Yes.
Yeah, I convert that.
How it is, Gaji?
What?
How it is that local session ID means that local port will be different?
Yeah. Obviously, those are what do you say? Those are the what is it? Those are the upper port number. That would be random port number. This is the those are not a well-known port number. You can use the computer. Your computer will use that. Okay, 65,535. Can you see this number?
Okay, but whatever.
Your source port number.
Yeah, but the session layer is gonna pick whatever ports can be.
Random port number.
Yeah, it would be random port number. It depends upon your application, your operating system, Abdullah, what it use. Okay, it might uses 1025, it might use 1026. Okay, it can randomly pick up any number. Okay, between this range. Got it?
Okay.
Okay. Now I said.
One more.
Okay. Yeah.
So in the segmentation, does it put the destination ID?
Connection ID.
No, destination ID address, like where the packet has to go.
Yeah, it would not yeah, that's what it uses a source port number. By looking at the source port number, my connections, my what do you say, my transport layer knows where I need to send the data. So if I open this browser, right, I told you, right, I have two session here, google.com for this also, google.com for this also. This guy will have a different source port number, this guy will have a different source port number. Got it?
Okay.
This is how it comes to know where it needs to send the data.
But when it goes like let's say like the destination between the source and the destination, there is two routers. Okay.
What was the question?
And let's say there is between the source and the destination there is two routers.
Two router.
Yeah. So each time it travels from router to another, it has to find the MAC address, right?
Yeah, correct. It needs to find out the MAC address if it needs to send out the packet outside or inside.
Okay, and the MAC address is connected to which IP? Is it connected to the router IP or the destination IP?
Okay, so you are asking where it go and look for the MAC address, right?
Yeah. If you have the destination port,
Okay.
how does it know the ID of the router?
Yeah, that is not done by these connections. Okay, that is done by your ARP protocol. Okay, that would be the job of your IP layer, not the TCP layer. Okay.
Okay.
So basically, you are trying to say.
So it's always gonna in the packet. It's always gonna have the destination port, and the ARP is gonna figure out the MAC address with the next ID address.
You are right. That's correct, Abdullah.
Okay.
I will come to that ARP. Okay, in just I'm just in the next slide. I'm gonna explain you what is ARP and all. Okay.
Yeah, this is just my doubt from the article. I was confused a little bit.
No. This is everything on the your job of the TCP layer. Okay. The ARP job is it comes here in this side network layer somewhere. Okay.
Okay.
Yeah. So now you are just need to worry about I got the source port number, I got my destination port number. Got it? I've created a segment, right? So always remember when I'm sending a data, I'm doing something known as the encapsulation. Okay? Means I'm taking this data,
Okay.
I am putting that into my segment. Okay? I'm gonna put one TCP segment there. I'm gonna put a TCP header. I'm not talking about much about TCP header. Okay? TCP header will have a source port number. It will have a destination port number. Okay, you need to understand that. It's really important. Source port number, destination port number, and it have other data as well, like sequence number, acknowledgement number, and all. Now you, for this conversation, for this class, you understand that the transport layer, the segment will have a TCP header. I take a data, I put that into my a segment. I will encapsulate data into the segment. I will also put the TCP header. That will become a segment for me. Got it? Got this?
Okay.
So if I draw this like this, uh, I have a data here, right? I have a data and I have a data here. I have a segment here. The segment is itself is a TCP header, which is 20 bytes. Okay. You don't need to worry about the bytes for right now. It's a TCP header. Okay. And you will have this data. Okay. Got it? And this we call as a segment. Hey, Nilesh, you got it? We lost them.
Yes, Gajan. No, I'm here.
Okay. You got it right? How the segment is created?
Yeah. So, is there any standard format like this type of segment, like any bytes size or something like that?
There is no bytes actually. You are asking what is your question exactly?
No, the segment
IP
is
format.
Yeah.
yeah.
How?
IPv4 format or IPv6 format.
No,
Right.
that actually segment is itself is the segment is basically will have a TCP header. Okay. You will see. I will show you the actual packet capture for that. Okay. How does the
Is
segment look
there a
like?
link for the packet?
What?
A link, like how many bits in the packet?
Yeah, that would be,
In the segment.
yeah, on the segment, right? Good question. That would be, uh, that would be derived from your MTU. Do you know what you mean by MTU?
No.
Yeah. So MTU is actually, let's say this is an interface, right? This is your computer interface, right?
Okay.
This computer interface have some certain limit. Okay, it can send a data at certain limit. Let's say that limit is actually called the MTU. Okay, it can send at
Okay.
one time 1500 bytes itself. It cannot send more than more than that byte. Means in one packet it cannot send more than that byte. Okay, that's called as the MTU. Okay, when I'm saying 1500 bytes, I need to remove 40 bytes. Okay, 40 bytes, the 20 bytes is from my TCP header. Okay, again 20 bytes from my IP header. How many now? If I do minus 40, how many now? What is the number?
1460.
1460 is your segment. 1460 is your data.
40 for the TCP.
What?
What for what?
This is what
Gajan, 20. Yeah.
this is what I am answering your question. You said how many data should be there, right?
So
Yeah.
24 TCP header.
Yeah, 24 TCP header, 24 IP header. I will talk about IP header next. Okay. I
Okay.
told that TCP header will have a source port and destination port number, right?
Yeah.
Yeah. Then there is a when the packet sent from the transport layer to the network layer, I will have a IP header because IP header required to do a IP routing, right? That also will have a 20 bytes.
Okay.
So I have a 40 bytes, 20, 20, 40 bytes. Then I do minus whatever the MTU. MTU might be your MTU might be 9000. Let's say you have a big computer like server that could uses 9000 bytes. It means it is capable of sending a 9000 bytes. Okay, in one packet. So then it would be minus 40 like this. Always
So
minus
that
40.
40 is standard.
Yeah, is 40 standard.
I have a question.
Yeah. Yeah, Abdullah, you can ask your question.
So the format, even if you're connecting to another device, so you have to take the data to decrypt it. So is that gonna be different? Like if the MCU is different?
Yeah, MTU is depend upon your computer hardware capability. It might be,
Okay.
yeah. See, your computer and my computer is a normal computer, right? It is not a server, right? So these computer will have a
Yeah.
MTU of 1500 bytes, and if you say a very high, the computer, the company uses like server, a big server, they will have a MTU more than 9000 bytes. Okay, you just need to do minus 40 from there, and you will get your
Okay.
actual data. Okay. Okay, your actual data is called as a
Okay.
maximum segment size. That's called the MSS. Okay, I just don't need. This is actually, if I try to explain this, that will be a lot of thing. Okay, so you just understand MSS is 1460. How I get it? The MSS is my actually data itself is the data. Okay, how I get it from doing a minus 40.
Okay.
Minus 40, I got my MSS. This is my actual data. MSS is called as actual data. Got it?
Okay.
Yeah. So now,
20 for the TCP and 20 for the IP.
yeah, you are right. 24. You can write it down. 24 IP header, 24 your TCP header.
CCNA.
Yeah.
Okay.
So MSS is the actual data that I am sending,
You are right.
right?
You are right, Nilesh.
In one
You
packet.
are right, Nilesh. That's correct.
Okay. So that 1460 we call MSS.
You are right, Nilesh. That's why,
Got it.
yeah,
Whether MSS full form?
it's the maximum segment size. Maximum segment size. You can say the name itself is telling you maximum segment size. Your segment size is only could be 1460. It's a maximum what you can send. Above that you send, you will do something known as the fragmentation. Okay, let's talk about the fragmentation in different class. Okay, if you are sending more than the data, then your router do a segmentations at some places. Okay, so your actual data should be, I can take a one more class for these because those MTU and segment, those are very important concept. Okay, for that I can take a different session for you guys. Okay, so for right now you understand
Okay.
MSS is like 1460 it would be. Okay, and how it is the maximum data what I can send at one packet. Okay,
Okay.
understood, Gopu?
Yes, Gaja.
Yeah. So now I got my TCP, right? TCP DAW. My HTTP uses a TCP because TCP is very reliable, and he will make my job very easy. Means I will be able to browse very easily. If there is issues in my data transmit, the packet will be retransmitted. That's why my browsing always uses TCP. That's why when you type something, you will get it. Anyhow, you will get it. You need to wait for some time, but still you will get it, right? But if it is a UDP, you will not get it back. So that's why whenever you do anything in your browsing, whenever you get your data, it would be late. It would take some time, but you get it because it's only because of your TCP. Okay. Now I am done with my transport layer, right? I got my TCP segment. I've added that. What happened next? Okay, what happened next was called the at network layer. Network layer, what is the job of the network layer, Nilesh or anyone?
To route the information to particular destination.
Yeah, uh, yeah, correct, that's correct. It does a routing lookup. So how does it does a routing lookup, do you know, guys? What is used to do a routing
Uh,
lookup?
ARP, it has to connect all the IP to the MAC addresses.
No, I'm talking about the IP. I'm not talking about the MAC address.
Routing protocols, right?
Yeah, yeah, IP itself is a routing, right? IP can alone itself is do a IP job is to do a routing. Okay, but see your protocol, right? OSPF and everything, these protocol just provide information, that's it. That those guys just provide a network information, that's it. They will not do a routing for you. Your routing done by your IP itself. Okay, those guys will give you the information. Those guys will give you the information about the to the IP to do a routing lookup. Got it?
No, can you come again?
Yeah.
I didn't.
Yeah, so basically IP job is to do a routing for you. Okay. Internet protocol. IP is the protocol which does the routing. Okay. How it does the routing? By looking into the routing table. Okay. I think you guys know right about the routers, right? All the routers will have a routing
Yeah.
table, right?
Yeah.
How does your PC does routing then? Nilesh, does it have?
Sorry,
How does
come
your
again.
computer does the routing? Do you don't run anything, right? You don't run a OSPF here or anything like that. How does it does the routing?
PCs also have IP address, right?
Yeah, it has a IP, right? Yeah, you are right. It has IP address. Then what it does?
Look in the routing table.
Yeah, you are right. That's correct. Gopu, there is a routing table in your router in your PC as well. Okay,
PCF.
you know that, right?
Yes. Yes, guys.
Loud. Yeah.
Yeah. So basically, that is actually how. What is the command for that? You do this CMD, right? You do write route print, right? You get your routing table. This is what my PC does. And what is how I'm communicating with you guys? I'm communicating with you guys or with this address, default address. That's what is my gateway is. That's how we are connected. Okay, this is what it is. See, whatever the information I'm sending you now, right now, I'm sending you to this gateway. Okay, this is what a default routing table is. Got it? And
What is that command, Gajanan?
this is the
Means
command you can add the command as well. This is route add. You can put routing here. Okay, there's a command for that. You can put bogus.
okay,
Yeah,
okay.
you can have a I this like this is the command for this. Yeah, I actually okay. This is the, can you see this route add? This is the command. You can add the route here. Route add and route delete, whatever you want.
How do you check the routing table?
This is the command route print. You can write it down. Very important command.
Route
This.
print.
Can you see this command?
This,
Route print.
Yes.
Write it down.
this is just on Windows, right?
What?
Just for Windows, or it also works for Linux?
Linux, I don't know what is the command basically. It might be a different command for Linux. You have to just look into it. Okay.
Okay.
This is how you can add something. Okay. Route add, and these are the command is telling you how to as the route change. Those things you can add it. Okay. You can delete the route as well. Let me type this route add 4.2.2.0 2.8, and I think that's the command 24 255 0 the relation will not on. Yeah, yeah, there is a command for that. Okay, you just need to add this command. Okay, it will give you the route. Okay, this is how it does. Okay, got it?
But we don't use this, right?
You can use it. You can use it. You can use it. So let me just tell you how to do that. This is the route addition. Okay, in Windows 7.
I think they will do these commands in servers, right?
Yeah, they can do they can do that in the server as well. They do that. Can you see this is a command you need to add route minus p add and whatever the mask. If I type it here like this, route minus p and whatever. Okay, you got it right. So just it just adding a routing table in your router. That's it. You do IP route, right? The same thing you need to do in the computer itself. Okay, and your computer will have a specific routes. Okay, got it?
Yes.
And now you guys go know, right? This is what OSPF does. OSPF will not do a routing for you guys. OSPF just do a get this information for you. When I do route print, okay, any protocol will give you the information, right? They will give you the information what exactly it is. These information is given by. Here I am manually typing it, right? Here I am manually typing it. If I am using any protocol, they will provide the information, and my IP will do a routing lookup. Got it?
Yes.
Got it, Abdullah?
So
Yeah, yeah.
okay.
Okay. Now, after this, what happened? I did a now I if I do any kind of routing, right? I need to have a source IP and destination IP address, right?
Yes.
So that's what my IP does. IP also takes this data, whatever data that will be encapsulated into my IP. Okay. Now I'm calling this as a packet. Okay. This is now called as a packet. Okay. In that IP header,
What IP it includes? The destination or the next?
yeah, this will include source IP and destination IP address in the IP header. I
Okay.
told you about 20 bytes, right? I told here that 20 bytes for TCP header and 20 bytes for IP header, right?
Correct.
Yeah. So 20 bytes for
Okay.
this source IP and destination IP. Okay. Got it? Yeah. And again, one more thing.
So out of the 20,
Yeah.
out of the 20 bytes, how many bytes we use for this?
No, we
IP,
use
source
yeah,
and
we
destination.
use all the addresses like source IP, destination IP. There are other fields as well. All the things. This is the like 20 bytes is a fixed. Okay, you cannot change it. That the IP header is a 20 bytes. You cannot change that. Okay, that's fixed. It might go
Okay.
more than that as well, but that is fixed. Okay, 20 byte IP header is fixed, and TCP header also is fixed. Okay, so that you cannot manipulate
Okay.
basically. Okay, there are some data in that like TTL and other things. So first, now you remember like I have a source IP and destination IP address in my IP header. Got it?
Yes.
Okay. Now what happened next? I got my IP header. I take the whatever the TCP I'm there here. I take that encapsulate into the IP header. And one more question, right? One more question for you guys. Okay. Now I said. Now I said that right. How does let's say how does a transport layer when I put here right? I told right I put a transport layer data here right on this side, right? You are right, right? Hello?
Yes.
I've taken the data of TCP. I've put this on this side, right? Correct?
Yeah.
So now there is a field in the IP header, right? That will tell the other side that this data, whatever I am having, it is belongs to my TCP header. Okay? That field we call is a protocol type field. You need to write this field, okay? This is the protocol type field.
Type.
Got it? This is the that
Field for the IP.
yeah that is a part of IP header. I will show you that what it is, okay, in the packet capture. Okay, so this is the protocol type field that will tell that whatever the data I'm having, that is a part of TCP. Okay,
Okay.
that would be some specific number. I think for TCP it is the port number 6. Okay, UDP it would be having the port number of 17. Got it?
So what is 53?
Which one?
Because we used to say about TCP is port 53.
Port 63.
53.
53 is a DNS. It's not a TCP.
Oh, okay. Okay.
So this is these information will be there in this protocol type field. What it is, whether it is because other side should know, right? Other side know that where I need to send this data, whether to TCP or UDP, right? By looking at this field, it will come to know that needs to this data needs to go to the TCP. Got it? Got it, Gopu? What is this field is all about?
Yes,
Yeah.
yeah.
Now I've sent this information.
First data,
What?
first data, then protocol type field, then the ID destination and source, right?
Yeah, correct. Source IP, destination IP address, protocol type field here, very important. Then here on the TCP side, it is the TCP port number, it is the destination port number. Got it?
Okay.
Now I come where? Now I got a IP packet. What happened next? I need to send a what is the next thing my IP does? Let's say my Google server inside in my network. What it does? Nilesh?
Can I send to the Gaga server?
Yeah. Before that, what it does, Nilesh? If the Google server in the same network, let's say Google IP address is the same IP address of your computer, I mean they are on the same VLAN, same subnet. What happened? What it does?
It will identify that MAC address ARP entry.
You are right. That's correct. It identifies that ARP entry. You are right. So what it does to identify ARP entries, what it does, Abdullah?
Can I send the ARP request?
Yeah. Before it directly send a ARP request, directly it gonna send an ARP request.
First, it's gonna check the table. If the MAC address is connected, it's just gonna send.
You are right. That's correct. Okay. First, it basically look into the table like this, ARP minus A. If you want to see here, it will look into this table whether is there any kind of, this is a local cache. Okay. It will check is there any addresses that is bonded or not. That's really important. If it doesn't have any address, it's gonna send an ARP query. Okay. It's gonna send an ARP query and it's gonna get an ARP reply. So why it does a ARP query? Nilesh, are you there? Hello.
Yes, Gajanand.
Why it does a ARP query? My IP layer. Why it does a ARP query?
To get the information,
What informations?
like destination, what do you say?
Okay, MAC address, right? It needs to get a MAC address, right?
MAC
Yeah.
address.
So
MAC
yeah.
address.
So what if my google.com is outside? Abdullah, what it does? To which guy it send ARP?
Gonna route to the router, and the router gonna check the table.
Yeah, that would be the router call is the default gateway, right? If
Yeah.
it is outside, it's gonna send a default gateway, right?
Yeah.
How does Gopu it comes to know that my google.com is outside of my subnet?
We have IP address, right?
Yeah, how it comes to know what it does, what kind of calculation it does?
It will check in the routing
Subnet
table.
mask.
Yeah, it basically takes the IP address and do some kind of AND operations. Okay, it get a result and it do AND operations with the other as well. It get a two results. It compare them. If it is like a belongs to the same subnet,
It do what?
it basically does the AND operations. Okay, just the AND operations. Basically, it takes the data. Okay. This is AND operation. I think I don't want to go in details for that. Okay, AND operations. You might have a calculation for binary number, right?
You mean the net?
Yeah.
The net mask?
Yeah, you are right.
Check if
AND
it's,
operations, OR operations. Yeah.
same local network or this.
Yeah. Got it? So it does it.
It's subnet mask, right?
Yeah, this is the bits and you know, right?
Yeah.
0, 1, and yeah. Basically with the subnet marks. Okay, it get the both the address. It compare them. It is fine. Then it comes to that where it belongs to. If it is outside, it's gonna send a packet to the default
If
gateway.
not, it's gonna send it to gateway.
Yeah, correct. You are right. Got it?
Okay.
Now,
Yes. And the gateway is gonna check. It's gonna ask the other router who has this address, right?
yeah, gateway will do these three steps again. What we'll talk, because gateway is called the lazy devices. It's gonna do the three steps again. The same step what I'm telling now. That's the gateway does. What computer does, that's the gateway does. Okay, it doesn't know anything that better than that. So now I set a packet to TCP, right? I put now I made an IP packet, right? Now I got my MAC address through my ARP. What I will do with this MAC address? What thing I will create? Nilesh,
Yeah, Gajanand.
after packet, what I will see next?
it will convert, means it will
It
convert
will
it
create
into
a
frames.
frame, right? Ethernet frame, right?
Yeah,
Yeah. So it basically will
yeah.
have a Ethernet header there, right? Right?
So Gajan, one question is here,
Okay.
like the difference between packet and frame is like frame will not include any IP address, correct?
You are right. Obviously, frame will have a Ethernet header. See, you just differentiate them
Ethernet.
by using their header. That's it. Okay.
Okay.
IP will have IP header. Ethernet will have Ethernet header. TCP will have a TCP header. TCP segments.
So this frame is okay. So this frame is a part of that 20 KB IP packet, like IP header.
Yeah, basically we are doing an encapsulation, right? I told you, right? We take a TCP
Okay.
data, we'll put it here, right? Now we'll take a packet, we'll
Hmm.
encapsulate here, right?
Yes, yes, right.
Now question is, what is, how do I identify that the packet is coming from the IP v4, not from IPv6? What is the field we use in the Ethernet header? Hello? Gopu,
just a second. I have to check. Yes.
Gopu, you know this answer?
Yes, Gajan.
What is that field?
Type field.
Yeah, that's called the Ethernet type field, right? Correct?
أعطيها مصرية ولا؟
Hey,
بس حقت
hey,
سان دييغو.
hey,
Correct.
Nilesh, you are understanding right what I'm saying here?
أعطيهم حقت سان دييغو.
Yeah, Gajan, what I understood is that how that frame will come to know whether it is coming from IP4 or IP version 6,
Yeah,
right?
yeah. That's what by looking at the Ethernet type field. The other side will come to know that. Okay. So this guy's job is to put that informations because I'm encapsulating everything, right? I am, you can say encapsulation like a multiplexing. I'm adding all the bits, like all the data together. Okay. Then other guy need to do a demultiplexing. He needs to look into the fields and he needs to he needs to remove some of the field by looking into some of the fields. Got it? Got it? Hello?
Yes, Gajan. Good.
Hey Abdullah, are you there? Hey Abdullah?
Speaking on phone, I think.
Yeah. So we are almost done, okay? So hello?
Yeah, Gajan, I can hear you.
Hey Abdullah, are you there?
I think he's there talking with some other
Okay,
person.
just 1 minute. I will just show this everything in one capture, okay?
Yes, hello.
Hey Abdullah, we were talking about this, okay? We were telling that now we got the MAC addresses, right, from the ARP, right?
Yes.
So now I'm gonna build a Ethernet frame. I take the packet, I encapsulate that into the Ethernet frame. Okay. I'm gonna put a source MAC address. I'm gonna put a destination MAC address. Okay.
Okay.
And now I am gonna.
This is the Ethernet header.
You are right. Correct. This is the Ethernet header.
Okay.
Then Ethernet header is actually how many bytes? Any idea?
Same as Mac and
No. It is not same as IP. It is a 14 bytes header. Okay. It's a 14
no,
byte.
same as the Mac address.
Yeah. It is a 14 byte address. 14 byte. Okay. It don't if
14.
14 4 bytes.
Okay.
It includes the frame check sequence as well, which is 4 bytes, which make him 18 bytes of header.
Okay.
Now what I'm saying is I'm talking about like Ethernet type field. Do you know this field, Ethernet type field, what it is? in the frame.
It depends of the kind of transmission.
Yeah, this
Right.
is basically will tell the other side from where the data is coming from, like from whether, for example, whether I might have IPv4 sitting over here on network layer, I might have IPv6 also, right? The
Yeah.
other side of the data link layer must know, right, where it is coming from, where it is going, right?
Yeah.
So that is where. So this guy will tell, this guy will put the data. If it is IP, it will put this number 0x800. Okay. This is
Okay.
by looking at this field, it will come to know that this packet is belongs to IP, not ICMP, not to IPv6. Got it?
Okay.
Yeah. So now I got my frame, but this is what I call the frame, right? And frame will have one field called the frame check sequence. Do you guys know what is a frame check sequence?
No, Gajan.
Yeah, the frame check sequence is a what do you say, the error checking mechanism. Okay, and one more thing I want to tell you, like other all the fields
It,
will have their own checksum.
it delivers correct or no?
Yes, correct. It basically a CRC code which runs which basically checks the data. Let's say I'm sending all the data here, and this guy is calculated of FCS frame check sequence of 40. Okay, it calculated the 40. Okay, other side received it. Okay, he will do its own check. He will run his own CRC, cyclic redundancy code. It's just a calculation, just check the data, how many bytes are there. And if it is of 41, let's say if it is of 38, okay, let's say it is a 38, okay, that means the data is not matched, some data is lost, right? 38 is
Yeah.
not equal to 40, right? Right, I have some two number, I have a 2 bits less, right? So that means my
Yeah.
frame check sequence is failed, and that packet will be dropped, that frame will be dropped right there. Got it?
But how the other side?
Yeah, other side will use it to make sure
But how the other side knows
yeah,
this
yeah,
is
other side
not
will again do a calculations, he will run his own CRC, he will come up with its own result. Okay, he will run his own CRC, this guy will run his own CRC is just calculating the bits, we can say for now. Okay, it's just a what is the it's just algorithm which check the all the bits and put that into the frame check sequence field. Okay, now this guy sends through the wire. Okay, if the cable is bad or if the cable having some problem, then I might lose some bits, and this guy again do the recheck. Okay, he run again his,
and check with the
yeah,
field.
correct, he'll come up with his own result. Then he will check the both the field, if they are matching he will process the data, if it is not matching he will drop the data. Got it?
Okay.
You got it, got it, Gopu?
Yes,
Yeah,
Gajan.
you got it, Nilesh, what I'm saying?
Yes,
And
yes.
again, all other fields have also their own checksum. Okay, IP header will have the same thing, and TCP also have their own checksum. They will have own their own checksum. Okay, they have their own these kind of field they will have also. Okay, got it? Just to remember this, though other guys header also they will have their own checksum as well. Okay, now I got a data. Okay, I convert that into my what? What will be, it will be converted now?
Signals.
Yeah, that will be zeros and one, right?
Yeah.
Yeah, that's
Yes.
what I told. That's why I've explained that other thing. It looks us like just taking a data and converting back, but behind the scene it will go. It needs to go through all of this process, and then it will become 0 1 0 0 whatever, and that will be converted into my what do you say? That will be converted into my electrical signals. Got it? Now the packet will be sent, and I think
Okay.
you guys know what happened other side. It is just a de-encapsulation. Okay, other receiver end, when the server side Google server receive it, Google server does de-encapsulations, means he will remove the Ethernet header. Okay, he will send a packet by packet to IP layer by looking at the Ethernet type field. Okay, again the IP layer look at the protocol type field, it go and send a packet to the TCP header. TCP looks the port number 80 and he will send a packet to the HTTP, data to the HTTP. Got it? Then the server will go through the same process again and the final packet B will be sent back. So basically when I'm sending something, I'm going from the encapsulations. Okay? And when I'm receiving something, I'm doing a de-encapsulation. Got it? Any question here?
Yes.
Any question?
No.
Abdullah, any question? Do you have any question here? Hello?
No question, Gajan.
Okay, I think I lost Abdullah again.
Yeah, we lost him.
Yeah, Abdullah, are you there?
So Gajan, the other end also,
Yeah. Yeah, Dinesh.
no, other end also FCS will happen, right?
Yeah, correct.
So,
Other end also will run his own CRC, Nilesh.
Okay, so if they see there's some difference in the count, so again it will drop the
Yeah, they
frame.
will drop the frame. They will drop the frame. And then the retransmission is depend upon your whether you are using a TCP or whether you are using a UDP. Okay. If it is a
Okay,
UDP, the
so
packet
if
will
it
be
is TCP,
not retransmitted back.
okay. Then if it is TCP, then only again
Yeah, correct.
it will receive
Yeah,
a fresh
yeah,
packet.
correct. You are right. That's correct.
Okay, thanks.
Yeah, I'm just gonna show you guys how these things work. It will take like 15 minutes. Okay, then we are done. Okay, then we can.
Yeah.
I think you guys know, right, about GNS3, right? Okay.
Yes.
And for now, I'm just taking this small topology where I will make this guy have. You guys had food or FA0/0? Hey Abdullah, are you there or you are still? Hey Gopu?
Yes, Gaja.
So you are there, right? So I think I will just show you guys how this works, okay? Then just 15
Okay.
minutes.
Where is Abdullah?
Hey, Abdullah?
Yeah.
Yeah. So Abdullah, you know, right? What happened next? The packets get converted into zeros and one. Got it, right?
Yeah. I know.
Yeah, I'm just showing all these things just for like I'm just doing this lab, okay? I'll just show this in a quick
Okay.
minute.
How do you configure all this?
Yeah, this I will tell you. I think I will. This is come into the routing class, okay? This though you don't worry now, okay?
Okay.
I will teach you this.
Because I download the program, but I'm not able to use the router. I think there is something additional I have to download.
Okay. Yeah, this is just a GNS tree. Okay. Router 2 phase. Gopu, you know, right? These things you know, right, already.
Yes, Kida.
Interface, FA0, that's IP, OSPF, and yes, okay. So I'm just showing you how the packet goes, and then we are done. I'm just okay. IP address 231.1.2 P OSPF 10 here 0 on router 3. Let's go that. Interface FA0 slash my IP address 3D3 1.1.3. Right? Mhm. Okay, I will make this guy as a HTTP server. Okay, okay, okay,
Okay.
okay. Interface. Got it? Okay, so let's talk about it now. Okay, so I'm doing a capture now. Okay, I can make this as a HTTP server, IP HTTP server. Okay, this is a command to make it if you want to test it by your own. Just go to the router and make it as a HTTP server. So this guy is my server now. Just change the symbol. This guy is server, and this R1 is my client. Okay, he is my client. Right, that's fine. R1 is my client. Right. So now, hello.
Yeah.
Hey, you guys are able to see, right? My screen?
Yes, yes.
Okay. Now you got it, right? So basically, we are doing the same thing what we are going to do. Okay. I said this client gonna look into my server for a HTTP request. Okay. I go into the router one. What is the IP address? Okay. I'm not doing any kind of DNS resolutions. Okay. I'm just using the IP address directly. Okay. I'm just using the IP address directly here. So if you look at this, on R4, I have IP address of to show IP interface brief, exclude unassigned. Okay, this is the IP address. Okay, hello. Hey, Mirish.
Yes, Gajanan.
Yeah. So you're able to see me, right? I'm gonna do a telnet. I'm just trying to access the HTTP services running on this guy. Okay, got it?
Yes.
I'm gonna use the port 80, okay, and I will see check whether it's working or not. Abdullah, you are able to understand me, right?
Yeah.
Can you see this? Can you see this? It is opening. I'm able to open the port 80 now,
Yeah.
right? Everything happened now behind the
Yeah.
scene. What would the first thing will happen? It does the DNS resolutions, but it doesn't do any kind of DNS resolution here. I don't see any kind of DNS packet here. Why? Because I'm just typing IP address. My router is able to understand the IP address directly. It doesn't need require any kind of DNS resolution.
Okay.
The first thing my router does is the ARP resolution. Can you see this?
Yes.
The ARP packet sent to get the MAC address, because my 172, who this guy is outside. He's outside my subnet, so he needs to send a packet to router 2. So he's just sending a asking who is 192.168.10.100. He sent a packet, okay. And now can you see this? What happened
Yeah.
next? It
TCP
yeah,
connections.
it created TCP connections. Can you see this, right? It created TCP connections
Yes.
with this. Can you see now, Gopu, what we talked last time?
Yes, Gaja.
So this is what it does. Port 80, all the port 80 will be, and this is what, when you talk about TCP, right? This is the TCP header, okay? This is the IP header, and this is your Ethernet frame, entire Ethernet frame, okay? Now I told you about the field, right? So these are the field, okay? If you look at this, I have a type field. That's called the Ethernet type field. That will tell me the upper layer is IPv4. And if I go in IPv4, I will have a protocol type field. I told about TCP, right? This is the protocol type field. Okay. And now by looking at the port number, I will come to know that I need to send a packet to the application layer. That is my destination port is 80. And now if it is matching destination port 80, he gonna send a packet to the HTTP services. Okay. If it is anything other like FTP or other thing, it will be different port number. Got it?
Yes.
So now if I do something like if I if I just do something, if I just tiered it down, I've done a tier, I've tiered on the stations. Now if you go and see now, you will see fin packets. Can you see this? I told about like fin packet, right? Those are like 4 packets. He sent a fin packet now, he get an ACK packet. He sent a fin packet, he get an ACK packet. Okay, so my TCP will be always a 3-handshake shake, and my closing will be always a 4-way handshake. Got it?
Yes.
Now if I go and if I try something different that is not listening, let's say I'm trying to this guy google.com, and I'm trying something on a port 81, okay, and now this guy my server will send a reset for me. Can you see this? He will send a TCP reset packet. He's sending, no, I'm not sending to the port. I'm not having any port 81. Port 81 is not open on mine. That's why the port resolution is also very, very important. If I'm not using correct port, my TCP connection will break, and I will see the reset packet being sent. Got it?
Okay.
Got it.
Any question now? I think this would be fine for you guys. We have done a quick lab. Do you have any question on the lab? Any question on the packet flow?
No.
Any
I
question,
think
Goku?
it's fine.
No, Gaja.
Yeah, that's fine, right?
It's fine. Yes.
That's fine. I think today class, I think that would be fine. I think we spent around 2 hours today, so I hope you understood the concepts. Okay, and if you have any questions, you just can let me know. Okay.
Okay.
Sure.
Yeah. See you tomorrow. Okay. See you in next class.
Okay.
Thank you.
Thanks.
Thanks, Gaja.